I'm going to show you how to do a PCV. PCV is called a packed cell volume. There's a few things we've got here. One is a blood sample, and it's in an EDTA tube. You can see there, and it's a good idea to read the label and identify the patient, so you're ensuring that you've got the right patient and you've got the right blood sample. This is some plasticine here. There's different products like this. It's designed to plug the end of the capillary tube, which I'll show you. These are the capillary tubes. They're called capillary tubes because a capillary is a very thin, hollow tube, and liquid can flow uphill against gravity up a thin tube like that. Some of them are plain, some of them come clear like that. These ones are what's called heparinized, so they've got a bit of heparin on the inside of them. If you're using a blood sample which is in an EDTA tube, it doesn't matter if your capillary tube is plain or it's heparinized. It doesn't matter. The only time that you need a heparinized tube is if you're collecting the blood straight from the patient, that we don't do. So with the capillary tubes, after we've sucked the blood up, we plug it into the plasticine. So it's a good idea before you start just to squash the plasticine down so you've got some flat areas to work with. You can see I've got a piece of paper here, so I've got nice clean area to work on. I've got my gloves on, I've got my scrub shirt on, and I've tucked my hair away so I don't drop that in the blood. So first thing, grab your EDTA tube and you rock it gently back and forth to make sure it's mixed properly. So when we take the sample with the capillary tube, it's even, it's a representative sample. I take the lid off, I put the capillary tube in the end, I have my finger off the end of the capillary tube, and then you do have to tilt it a little bit on the side, but you can see the blood is flowing uphill. You need to be patient, you need to be steady. As you tilt it a little bit further, the blood tends to run a little bit further. So you want to fill the tube at least a halfway, preferably up to about 2/3 or 3/4 of the tube. That way you know you've got a good sample in there. And at the end we're also going to use the plasma from this tube, so it's a good idea to fill them as much as you can. Okay, that's reasonably full. I put my finger on the tip now. I make sure that the blood, I put the lid back onto the tube straight away, because otherwise you'll knock it off. Ooh, like that, that's not very good. I'll show you what I'm going to do. This tube I'm going to put into the plasticine. So I push it into the plasticine like that. I give it a little bit of a twist and a little bit of a turn. I pick it up again with my finger on the top. I push it again into the plasticine, a bit of a twist and a bit of a turn. I pick it up again, I push it in with a bit of a twist and a turn. I am going to get the lid on here. Now what you'll see is that there's a plug in the end of the tube, and you want to plug at least that big, maybe a couple more to make it a bit bigger. At this stage you can clean the outside of the tube to make sure it's clear. And that's the first step in the process. So I've got two capillary tubes full of blood here that I've filled up. As I mentioned, cleaning the outside of the tube is always a good idea. So if you just get a bit of water like this and you grab the outsides of your tube, that's always a good way to start. So here are the two tubes, and now we're going to place them in the centrifuge. So when you come to the centrifuge, you can see this is the rotor that spins around. The centrifuge is switched off at this stage. When you put them in, the tubes in, you make sure that the plug is on the outside, so the blood then is going to spin down and not go out the tube. So I've put it in the number 1, and I've put it in the exact opposite which is number 13, with the plug on the outside. So it's really important, the plug on the outside and balance the centrifuge opposite. Whenever you do the PCVs, you should always do multiples of 2. So do 2 or 4 or 6 or 8 so you can balance the centrifuge. We put the lid on. I close the lid, I lock the lid, I turn the power on, I set the speed, and I'm going to set this to 3 minutes. It's going to spin down. At TAFE, always the teachers will spin the centrifuge down. You can load the centrifuge, but please don't spin it down without a teacher. Okay, I've got my 2 capillary tubes and I've taken them out of the centrifuge, and this is what they look like. So you can see the plug on the end has stayed intact, which is good. If that comes out, blood tends to go all over the centrifuge, which is not good. You can see the red blood cells have been packed down the bottom, and then above that is the clearer plasma. Now this is hemolyzed a little bit. You can see the colour there, it's not clear. You can get white lipemic plasma or serum, you can get yellow, or you can get hemolyzed, which is a bit red stained. So we've got enough here to do a PCV. We need to do a PCV in 2 ways. One is by using a ruler and a calculator. This is a manual method, so everyone needs to know how to do this way. We've also got some readers here, so you need to be able to use a reader. I'm going to show you how to do both those ways, both those methods. Okay, so if we've got a capillary tube like this, you need to measure. Then there's 2 measurements you need to calculate. The first one is from the bottom of the blood to the top of the blood. So you're just measuring the blood column. So the blood column there is 33 millimetres. Sorry, I'm trying to write upside down for you. 33 millimetres. Now it doesn't matter if you use millimetres or 3.3 centimetres, you could use metres, as long as the measurements are all in the same units. So I like using millimetres. So if I measure that, the second thing I have to measure is from the bottom of the plug all the way to the top of the plasma, this one here. So I read that as 48. So they're the 2 numbers that I need. 33, which is the red blood cell column, and the second one is the entire column. Now, be really careful here. You don't measure it from the bottom of the plug, and you don't measure to the top of the tube. You measure from the bottom of the red blood cells to the top of the plasma and that junction in between. Once we've done that, this is what we do. You do 33 divided by 48 times by 100, and that is going to give you the answer, the PCV, as a percentage. So 33 divided by 48 equals, times by 100, the answer is 68, you round it up, which is 69%. That's a very high PCV, but that's what the answer is, 69%. So this is the manual method. Now let's have a look at the readers. There's a lot of different types of readers. You should become familiar with the ones in your practice, and I'll show you how to use these ones here. Now there's usually 2 steps in the process to reading a PCV with a reader. So the first one is to get this arm here out of the way, because you don't use that for the first step. The first step is to put the tube into this little rack, and like when you're measuring, you put the black line on the bottom of the red blood cells like that, And then you hold it in place, you slide it along, so this black line is on the top of the plasma. So they're the two things we measured with the manual. So they're the two places you need to line this up. Then after you've done that, you bring this second arm in place. You go right on top of, sorry, I'm just moving that a little bit. Okay, you go right on top of the red blood cell level, and then you go over here and you read the number. Now, that number is 71. That's what I read that as, 71. So 71%. Now you can see it's not exactly as what we got manually, but it's very, very close. 1 or 2% out is acceptable. So you should do both, and you should compare both the manual method and the manual reader. Okay, I've measured the PCV and I've finished doing those measurements. So I've got my tube still. We're going to move on to the TPP now. The TPP is the total plasma protein. To measure that, we need to use the refractometer. So we had a look at the refractometer the other day. This is the refractometer. Remember, this is the focusing dial here. This is the pane, the glass pane, and this flap comes down on top of it. First thing we do is we get some distilled water. We put the distilled water on and we calibrate. So to calibrate, you look down and you put the scale onto the bottom of the urine. So I spin that around, and so calibrating it, it's on the 1.000 on the urine scale. Now that that's calibrated, I have to get rid of this distilled water and make sure the refractometer is dry before we begin. So I use lint-free tissue to clean the refractometer and make sure it's dry. Now, this is the plasma we want here from this blood tube. So what we've got to do is to break the tube above that level. So I just snap it there. So it's above, that's probably pretty close, that one, but I want to snap it above the level of the blood. And now you can gently tap it like this. You've got to be careful that you don't get glass onto the refractometer. You can damage it. So you can just gently tap it like this, and you can see the plasma is now coming out. So if you put a bit of the plasma on the bottom like that and a little bit on the top like this, you can see Now, you need to continue to do that patiently. You might need to break another tube like this, so you've got enough, I'll show you this, so you've got enough plasma to get a reading, because if you haven't got enough liquid, when you put the pane down, it doesn't make a seal, and so you won't get a clear reading. Here's a warning for you. Some of the PCV tubes are not glass, they're plastic, and therefore they don't break. So that's no good. So make sure you choose the glass slides at the beginning. This one does. So you can get the plasma to run down either way. Sometimes it's better to make it run all the way down the tube to the clear bit where it hasn't broken. I'm just going to try to get this one done fast. Now you can see here with this, there's a big chunk of glass on the pane there, so I gently move that off. You don't want that, so I've moved that out of the way. So this is why it's really important that you spin down, 4 tubes or 6 tubes, a lot of tubes, because when you get the glass pane and you push it down, if you don't get a really good seal here, when you look down the refractometer, you won't get a reading. So I can't read that, so we need another 2 tubes to do it. In the end, when you've got enough plasma to get a really good seal there and there's enough liquid on there, you read from the serum plasma scale. The serum plasma scale is 0, 1, 2, 3, 4, 5. It goes from 0 to 9 or 10, something like that. And then you multiply by 10 and your answer is in grams per litre. So a typical serum protein level will be 65 grams per litre or something similar to that. At the end, you want to go and wash this all off with, under the tap, you can wash it off with the tap water, after tap water, dry it with the lint-free tissue and put it back in the container.